चलें ठीक है, we're all set to go. और ये मैंने गलत जगह खोल दिया, just one second, इसको मैं सही कर लूँ. And the data booklet as well. So ठीक है, let's start with the first question. Zaid, can you see the question? Can you hear me?
Yes, sir.
So this one is in which option do all three particles have the same electronic configuration and the same number of neutrons? So basically, he's asking which ones are isoelectronic. So पहले वाले में it looks like they have the same number of electrons because 7 3 minus means 10 electrons, 10 electrons, 10 electrons. So all of them have 10 electrons. In B also, they all have the same number of electrons. Because oxygen is 8, 2 minus means 10 electrons. All of them have 10 electrons. Pretty much all of them have 10 electrons. Just one second. Neon is 10. Sodium, I said this one doesn't. Because sodium would have 11 electrons. It doesn't have a charge. So the last one is obviously incorrect. And he's also saying, so the first three are it's any one of the first three. Fluorine is -1, that's 10. Sodium is +1, so that's also 10. All of them have 10 electrons. And he's also saying that same number of neutrons. So which one has the same number of neutrons? Uske liye you have to do some calculation. That's 7. Nitrogen is 7. So uske neutrons kitne ho gaye? That's 8. Oxygen is the protons are 8. 16 minus 8, that's 8 as well. And fluorine is 9 protons, so that's 10 neutrons. So that's definitely not true. The second one is going to be probably the correct one. Okay, oxygen is 8, fluorine is 9, and neon is 10. So all of them have 10 neutrons each. So it's the second one, option B. That's the correct one. So anyways, the next one is the shell of a chicken's egg makes up 5%. क्या गलत नहीं कर दिया? Just a second. This is, you may copy kar, just a second. It's 9-7. Sum of 15, question paper 1-2, okay? Anyways, next is the shell of a chicken's egg makes 5% of the mass of an average egg. The average egg has a mass of 50 grams. Assume that the eggshell is pure calcium carbonate. How many complete chickens eggshells would be needed to neutralize 50 cm³ of 2 mole per dm³ ethanoic acid? So I'm going to start, it's called reverse again. I'm going to try and solve this in reverse, starting with the ethanoic acid. He's talking about ethanoic acid. So ethanoic acid is CH3, COOH, and I think it's reacting with calcium carbonate. Okay, that's the reaction that's taking place. So what happens? You must know what the equation is. What happens is that there's going to be an acid-base reaction or a carbonate. A carbonate is a weak base. So the salt that's going to be produced is going to be CH3, COO -1, and Ca is 2 plus. So if you do crisscross, this would become 2. Plus there's going to be H2O and CO2. Anyways, we're not interested in the whole equation. What we're interested in is the ratio. The ratio of ethanoic acid to calcium carbonate is 2:1. Based on this, you can now try and figure out the moles of ethanoic acid. So you're given the volume and concentration. So the moles is concentration times volume. So that's Can anyone try and solve this? It's 2 times 50 divided by 1000. What do you get? Need 10. Mic किसी का on है, please.
0.1 mole.
Yeah, 0.1 moles. Take it divided by 1000, so that's 0. That's 0.1 moles. Okay. So you're getting 0.1 moles. So calcium carbonate के moles क्या होंगे? That would be, according to the ratio, that's 2:1. So the amount of calcium carbonate that is required, it's going to be half of that. It's going to be 0.05. It's going to be 0.05 moles. So we've figured this out that we need 0.05 moles of calcium carbonate. That is what we are looking for. So 0.05 moles of calcium carbonate, and we can find the mass of this. How do you find the mass of calcium carbonate? You can find the mass of calcium carbonate by, what's the formula of mass? It's moles multiplied by the MR, which is going to be 0.05, multiplied by the MR. So that's 40 plus 12 plus 16 into 3. That's 100. So that comes out to be equal to how much?
5 grams.
Kitna? 5?
Okay.
5 grams. Okay, that comes out to be 5 grams. I think that comes out to be 5 grams. तो अब उस पे आ जाते हैं. So this is what we know so far. We know that etheric acid, we know the moles of etheric acid, that's 0.1 moles. We know the calcium carbonate moles that should react with that many etheric acid, and that comes out to be, 0.05 moles, and we figured out the mass of calcium carbonate, that's 5 grams. So basically, we're looking for 5 grams of calcium carbonate. That's what we are looking for. How do you get 5 grams of calcium carbonate? So उसने दिया हुआ है कि the shell, अब ये first statement. Remember, we're looking for 5 grams of calcium carbonate. Now he's saying that the shell of a chicken's egg makes up 5% of the mass of an average egg. So, and he said that the shell is pure calcium carbonate. So 5% of 50 grams is pure calcium carbonate. What's 5% of 50 grams? 5% of 50 grams is basically 2.5 grams. So that's the amount of calcium carbonate that's present in one egg. Right? That's the meaning of the first statement. Okay, one egg which has a mass, an average egg which has a mass of 50 grams, uske andar 5% of that egg is calcium carbonate. So that's basically one egg is giving you 2.5 grams of calcium carbonate. And how much calcium carbonate do we need in the reaction? You need 5 grams. So one egg is giving you 2.5 grams. So how many eggs should there be? There should be 2 eggs. Okay, because you're looking for 5 grams. So the answer is 2. Okay, B is your answer. Okay, how many eggs do you need? You need 2 eggs. Okay, so that's your answer to this question. The next one, ये clear है ना सारों को? Yes or no? इसमें type कर लो basic chart के अंदर. The
Yes,
next.
sir.
So now the next one is, thus phosphorus forms a compound with hydrogen called phosphine. This compound can react with H+1 ions. What type of interaction occurs between pH3 and H+1? Now pH3 is this molecule over here, but it has a lone pair. It has a completely full outer orbital. All group 5 elements, they have one lone pair. And H+1, which is completely empty, has no electrons, is going to be attracted to those lone pairs, and they would end up forming a dative bond. So a dative covalent bond is going to be formed between them, between pH3 molecules and H+1. So that is what's going to happen over here. And the pH3 molecule is going to behave as a base. Anything that has a lone pair pretty much behaves as a base because it is capable of accepting H+1 ions. The next one is, which solid has a simple molecular lattice? So I'm going to to go one by one and discuss all of the solids. The first one is an ionic lattice. That's known as a giant ionic lattice. In a giant ionic lattice, calcium fluoride, you have a positive ion, which is attracted to a negative ion, which is then again attracted to a positive ion and a negative ion. So it's a giant ionic lattice. It just keeps on going. Positive and negative ions are all attracted to each other by strong ionic bonds. Nickel is metallic. What's a metal? A metal likes to lose electrons. So you have a bunch of metal atoms. They all like to lose electrons. They all form positive ions. And where do the electrons go? They don't have any place to go, so they're just roaming around. So that's a giant metallic lattice. So metal ions in a sea of free moving electrons. The third one is SiO2. That's a giant covalent structure where you have Si bonded to four oxygens. And those oxygens are then further bonded to silicon again, which is then again bonded to oxygens, and it just keeps on happening. It's a giant covalent structure like diamond. It's tetrahedral. Uh, so the last one, D, is the correct answer. That's a simple molecular lattice. Simple molecular lattice, sulfur is S8. That's the molecule of sulfur. In simple molecular lattice, you have tiny molecules that are not bonded to other molecules. So simple molecular substances are the only ones that are simple molecules. They have intermolecular forces. The simple molecules, they have weak intermolecular forces between them. So the molecules don't have bonds between them. All the other types of bonding, they are all giant structures. They're all interconnected. This forms, I mean, they're all crystalline. They all form these giant lattices, except for simple molecules, which have these intermolecular forces. That's the next one. This is an ideal gas question. You have, assuming the gas behaves as an ion, what is the mass of the sample of methane? So what we're going to do is we're going to turn this formula. I mean, the first thing is there are two versions of this formula. Remember, uh, PV is equal to nRT can be written as N is moles. So that could be written as mass over MR or AR. MR in this case because I think we're talking about methane over here, into 8.31 into the temperature. Now, the only thing you have to be worried about in this question is that you have to use the right units. Pressure should be in pascals. So if I start putting in these values, pressure should be taken as 103,000 pascals, not in kilopascals. The volume should be in meter cube, which is already in meter cube, so that's 5.37 times 10 to the power minus 3. Mass is what you're looking for, and I think for methane, this is a sample of methane, so the MR is already known, that's 16. R is a constant that's given in your data booklet. You should remember it. It's 8.31. And the temperature must be in Kelvin. So that's 60 plus 273. That's 333 Kelvins. Can anyone do the math and tell me what is the mass of the sample of methane? What are we getting? Zaib, are you doing this? Let's just somebody did that. This is coming out to be 3.19.
3.19.
So it's coming out to be 3.19. The next one is there's a metaldehyde, whatever that is used as a solid fuel for camping stoves. The equation for the complete combustion of metaldehyde is shown. Delta HC is the standard enthalpy change of combustion. Which expression will give the correct value for the enthalpy change of formation of metaldehyde? So he's asking for the enthalpy change of formation of metaldehyde. Now, the thing with this is you can apply a few formulas over here. One is that whatever this reaction is, He's asking for the enthalpy change of formation of metaldehyde. Now, in a reaction, if enthalpy of formation of the products and the enthalpy of formation of the reactants are known, uh, so for example, if you take this reaction and you know the enthalpy of formation, he's talking about the enthalpy of formation of metaldehyde. So if in an equation you know the enthalpy of formation of all the substances, then the enthalpy of that particular reaction is going to come out to be equal to, it's going to be equal to the products, the enthalpy of formation of the products, which in this case is going to be the enthalpy of formation of CO2, and that's going to be into 8. So products minus reactant. This is the formula that you should know, that in any reaction, if you know the enthalpy of formation of the products and you know the enthalpy of formation of the reactants, you can subtract the two to find the enthalpy change of that particular reaction. So you can do this over here.
Sir,
So enthalpy of hmm,
isn't it better to use Hess law when dealing with enthalpy change of combustion?
like Hess law and what? Like draw the Hess cycle.
Because yes, sir,
Huh?
because kabhi kabhi not using the Hess cycle in combustion enthalpy change of combustion questions की वजह से sign mistake हो जाती है.
नहीं इसके अंदर तो मतलब it's वो the last है. I mean if you're dealing with enthalpy of formation and combustion, just use the formulas, ठीक है? क्योंकि drawing the Hess cycle उसके अंदर ज़्यादा mistake होने का chances है. It's going to be very time consuming. I mean, this is also time consuming, but that would be more time consuming. क्योंकि इस question के अंदर simply क्या करना है? The enthalpy of this reaction is basically the enthalpy of formation of the products, right? Minus the enthalpy of formation of the reactants, ठीक है? तो if you start making the Hess cycle, it's going to take a very very long time. So उसके अंदर I would not recommend to even go for the Hess cycle if you're just dealing with enthalpy of formation and enthalpy of combustion. Especially in this case, TK, drawing the Hess cycle would kind of, if you're very good at it, then you can go for the Hess cycle. But simply a formula lagana, that would give you the answer. So product minus reactants, karo, it's products. This is one product. The other one is uh, 8 times delta HF of water, right? And then minus the reactant. So what are the reactants? The reactant is metaldehyde. So it's minus delta HF of this thing, this CH3CHO4. Okay, metaldehyde, whatever this is. Uh, and O2 enthalpy of formation is 0. Remember that. So products minus reactants. And the enthalpy of this reaction is going to be called the enthalpy change of combustion of metaldehyde. ठीक है, remember this would be known as the enthalpy. So ये जो enthalpy delta HR हमने कहा है ना, I'm going to rub this off and I'm going to start calling this the enthalpy of combustion of metaldehyde, because this is exactly what's happening in this reaction. If you look at this reaction, this is exactly what's happening, that metaldehyde is being burned in oxygen to produce CO2 and H2O. So I'm going to rub this off, और इस reaction को इसका proper नाम दूंगा. It's basically the enthalpy of combustion of metaldehyde. I'm just going to call it M. ठीक है, that's equal to this. And what you just have to do now is you have to rearrange everything, because he was asking for the expression to give the enthalpy change of formation of metaldehyde. So which is this one. तो इसको और इसको इन दोनों की places को substitute कर लो. So it's going to be 8 times delta HF plus 8 times delta HF of H2O and minus delta HC of metaldehyde. So 8 times delta HC of अच्छा उसने और भी ज़्यादा confusion create की है. Just one second. Let me write the expression first. The expression is, पहले तो expression rearrange कर लो. Is this clear up to this point? Or metaldehyde को I'm just calling it M. ठीक है, just writing the expression neatly. 8 times delta HF of Just 1 second. ये पहले मैं लिख लूं. अच्छा, minus delta HC of N. ठीक है, यहाँ तक हम आ गए. So remember, just a recap. पहले तो वो recap कर लें कि so that things don't get confusing. So the thing is, okay, what do we have so far? What we have is you're given the enthalpy of formation of the products and the enthalpy of formation of the reactants. To find the enthalpy change of this reaction, simply do products minus reactants formation, the product formation and minus the reactant formation, which is exactly what we did. Or that's equal to the enthalpy of this reaction. This reaction is the enthalpy of combustion of metaldehyde. Because metaldehyde is being burned in oxygen to produce carbon dioxide. So this reaction is basically the enthalpy of combustion of metaldehyde. And I made enthalpy of formation the subject of the equation, which is why I got this. Now the final thing is, okay, remember that for water and for carbon dioxide, remember this, that enthalpy of combustion of carbon and the enthalpy of formation of carbon dioxide, they're exactly the same thing. You get a lot of questions. They use this trick. They try to trick you into believing that there's something different. Remember, these two reactions and the enthalpy changes are exactly the same. Why are they exactly the same? Because what is enthalpy of combustion of carbon? कि 1 mole carbon को आप burn करोगे oxygen के अंदर and you will get carbon dioxide, right? So that's the enthalpy of that particular reaction. What is enthalpy of formation of carbon dioxide? That you're going to form 1 mole of carbon dioxide from its elements, which are carbon and oxygen. So you get, both of them are pretty much the same reaction. Enthalpy of combustion of carbon is C plus O2 CO2. Enthalpy of formation of CO2, that's you're making CO2 from what? From the elements, which are carbon plus O2. So they're basically exactly the same reaction. And similarly, the enthalpy of combustion of hydrogen is the same as the enthalpy of formation of H2O, because they both represent the same reaction. Okay, enthalpy of combustion of H2 is basically H2 burning in oxygen to produce H2O, and enthalpy of formation of H2O is you're making H2O from H2 and O2. So it's pretty much the same reaction. Both values are exactly the same. So this is the expression that we had so far reached, and we're going to modify this expression. What we're going to do is we're going to change in do ki jagah. Now what we're going to do is we're going to substitute enthalpy of formation of carbon dioxide with enthalpy of combustion of carbon. So it's 8 times enthalpy of combustion of carbon plus 8 times enthalpy of combustion of hydrogen minus the enthalpy of combustion of metaldehyde. So the answer is going to be, it's going to be C. Okay, that's going to be your answer. Is this clear?
Yes,
Yes,
sir.
sir.
And remember, in MCQs, when you see a question like this, just skip. Okay, just go end pay because it's a 1 mark question. Make sure you do the easy ones first. Next one is copper metal is purified by electrolysis. Electrolysis is not in your course anymore. 2015 it was, so forget that. There's an equilibrium reaction. Which conditions give the greatest percentage of N2O4 at equilibrium? So you want the equilibrium you want it to be pushed to the right, okay, forward direction के अंदर. So how would you do that? Pressure high or low?
Hi.
Okay, so it's going to be high pressure, and the temperature, because it's an exothermic reaction, it's going to be favored by low temperature. Okay, low temperatures favor exothermic reaction, so the answer is going to be B. Next is about, okay, this one is about Kp, and what's happening here is, just a second. So what's happening here in this question is that this when a sample of HI is warmed to a particular temperature, the equilibrium below is established, and at this temperature, it is found that the partial pressure of HI, you're given the partial pressure. Partial pressure of HI is 28 times the partial pressure of H2. So let's say H2 ka partial pressure, that's X. So that's the partial pressure of H2. The partial pressure of HI is 28 times. So that's going to be 28x, right? And so what would be the partial pressure of I2 then? So if you look carefully, initially a sample of HI is warmed, right? So right at the beginning, right at the beginning, there is no I2 and there is no H2. There was only HI, and HI was getting decomposed, right? I mean, that's probably, I mean, where do you get H2 and I2? Because HI probably reacted, right? So HI reacted, ended up forming H2 and I2. So that's what's happening. तो अगर जो भी random moles बने, ठीक है, अगर 10 moles H2 के form हुए, then I2 moles would be exactly the same because it's 1:1. क्योंकि initially he did not add any H2 or I2. उसने सिर्फ he just took a sample of HI and that eventually probably decomposed. So the moles of H2 and I2 would be exactly the same. So the pressure that would be exerted by H2 would be exactly the same as the pressure that would be exerted by I2. क्योंकि exactly same moles है. So the same number of particles of I2 would be bumping into the walls of the container. The same number of particles of H2 would be also bumping into the walls of the container. So ये आपके पास, this is what you're getting. And the next thing is you're going to write the expression for Kp, which is products over reactants. So it's going to be pressure due to H2 multiplied by the pressure due to I2, and you divide it by the pressure due to HI. But that's going to be squared. Okay, products over reactants. Remember, the coefficient becomes the exponent. It becomes the power. And substitute the value, so it's going to be x into x divided by, I think, 28x squared. Divided by 28x whole squared. So the x would get cancelled out. It's going to be 1 over 28 squared. Okay, all the x are going to get cancelled out. And that's what you're going to have. So क्या बन रहा है?
A1.
Because A. I say you're getting A. Today you're getting A. Next is photochromic glass used for sunglasses darkens when exposed to bright light and becomes more transparent again when the light is less bright. The darkness of the glass is related to the concentration of silver atoms. Okay? So what we're doing, what's happening probably is, okay, silver atoms, if they are forming, then it becomes dark. And if silver atoms are changing back into silver ions, then it's probably turning light again. So which statement about these reactions are correct? So the first one kind of looks correct. Okay, copper plus 1 and copper 2 plus are acting as catalyst, because if you look over here, copper plus 1 changes into copper 2 plus, and copper 2 plus changes back into copper 1 plus. So they are kind of behaving as a catalyst in this reaction. I think the first one is probably the overall reaction. They remain unchanged. Anything that remains overall unchanged in the reaction, that's probably behaving as a catalyst. अच्छा, अब उसके the other one is copper plus 1. Like we can check, or we can go through all the other ones as well. The other ones are, okay, copper plus 1 is acting as an oxidizing agent in the reaction. Copper plus 1 is getting oxidized in reaction number 2. So that one is wrong because it's getting oxidized, which means it's acting as the reducing agent, not as the oxidizing agent. Look at reaction number 3, increases the darkness of the glass. If you look at reaction number 3, so silver atoms are changing into silver ions. So the darkness would decrease actually, because silver is silverish, so that's going to block the sunlight. So if the silver atoms are gone and they form ions, uh, then the darkness would decrease, not increase. And silver atoms are reduced in reaction number 3, which is probably also incorrect because they're getting oxidized. An atom changes into an ion. So they are getting oxidized. तो सिर्फ A बनता है. अच्छा, next one is Boltzmann distribution. So which statement correctly describes Boltzmann distribution is that you have, it's the distribution of molecular energies. ठीक है, low energy पे number of particles. If you have any container or any room that's full of gas, the number of particles at high energy, very high energy, and very low energy, that's very few. Height जो है ना, that's the number of particles. Most of the molecules have energy that is close to the average energy. Okay, if your room is at 25 degrees centigrade, then most of the particles would be around 25 degrees centigrade. Well, some of them would have more kinetic energy. They might be at 28 degrees centigrade. Some would be lesser, but most of them would be around the average energy. So the most number of particles, you're not going to find any particle that, or very few particles that would be around that would have energies that would be 100 degrees centigrade. तो यहाँ पे height कम होगी. अच्छा, which statement? Now he's increasing the temperature. What happens to the distribution when you increase temperature? So it's going to get skewed like this. Okay, high energy number of particles would increase, and the low energy number of particles would decrease, because now overall the container or whatever the gas is, it's at a higher energy. Or जो average energy है ना, which is over here, वो higher energy. Now the average energy is much higher. ठीक है, I mean the peak is going to shift to the right. So fewer molecules possess the most probable energy value, and this shifts, and the value shifts to the left. So the first statement looks correct. Most probable energy value is this one, जिसको हम average energy कह रहे थे ना. This is the most probable. I mean, most number of particles are at this energy. पहले वो most probable energy जो थी, that was much lower. ठीक है, that was somewhere over here. This was the particles. This energy had the maximum number of particles. But now the most probable energy value is over here. So why do we call it the most probable? Because most of the particles have this energy, right? So this value shifts to the left. Just a left likha hua hai. That's incorrect, because the most probable energy value is shifting to the right, which makes A wrong actually. Okay, is this clear?
Yes, sir.
Yes, sir.
So next one is fewer molecules possess the most probable energy value, and this value shifts to the right. So that kind of looks fine. Remember the height decreases. Okay, the height decreases because if the particles are distributed over a wider range of energies, then तो किसी भी एक point पे ना, the amount of particles would be lesser because they're distributed at a much wider energy values. So the height decreases. मतलब पहले उसकी height जो थी वो यहाँ पे थी. Now the height is much lower. So fewer molecules possess this most probable energy value, and the value shifts to the right. So B looks correct. बाकी भी देख लेते हैं just to be sure. More molecules possess the most probable energy value, and this value shifts to the left. That's also incorrect. The area under the curve of the distribution increases. Remember, the area remains constant because you have the same number of molecules. तो जिस तरह वो हिस्टोग्राम में होता है कि वो molecules इधर distributed है या वो इधर distributed है. I mean, the more widely they're distributed, and जो higher energy वाली value जो है, that's much further away, the number of particles are going to remain exactly the same. The area under the curve would remain exactly the same, because the number of molecules are not changing in the container. So B is the answer. Achha, फिर next is there's a anhydrous nitrate of a group 2 metal, and it's being decomposed, and 1.53 grams of a gas is being produced. Now there are two ways of solving this question. One of the ways is कि बारी बारी सारों को सॉल्व करना शुरू करो और फिगर आउट करो कि ये जो डेटा है ना, दिस डेटा which compound does it match with, and they're all group 2 nitrates. The other way to solve this is take this group 2 metal as being M, right? Unknown. The decomposition of a metal nitrate for a group 2 metal is going to look like this. Okay, it's going to produce a metal oxide, it's going to produce 2 NO2 molecules, and it's going to produce half molecules of oxygen. Okay, so that's your decomposition equation, and it is a balanced equation. Okay, remember, one way is you take beryllium nitrate, 3 grams low, or देखो कि figure this out कि 1.53 grams of gas is being produced or not. लेकिन that would be time consuming because you would have to do it for every one of them. और फिर जिसके साथ ना 1.53 grams of gas is being produced, that would be the right answer. The other more generic approach would be that just take metal nitrate and अच्छा इसका क्या करना है? इसका what you have to do is take the metal nitrate and how many grams is this? This is 3 grams, right? How many grams of what mass of gas is being produced? That's 1.53 grams. So this over here is 1.53 grams. So ये जो होगा ना, this is going to be 1.47 grams. अच्छा, just focus on metal nitrate and metal oxide. Both of them, the moles are exactly the same. Okay, 1 mole produces 1 mole. 2 moles would produce 2 moles. 20 moles would produce 20 moles. So they have exactly the same number of moles. Find the moles of both of them. This would be 3 divided by the MR. The MR would be, I don't know what M is. NO3 twice is 124. Let me just check. That's 14 plus 16 into 3. That's 48 plus 14. That's 62 into 2. That's 124. So those are your moles. अच्छा, इसके भी moles निकाल लो. That would be mass divided by the MR, which is M plus 16. And both moles are going to be equal. So you just have to solve this. Because the mole ratio says that whatever the moles over here, the same moles of MO would be produced. So just make them equal and solve this. So it's going to be 3 times, just make them equal and start solving. So it's going to be 3M plus 16 into 3, that's 48. And on the other side, it's going to be 1.47M and 124 times 1.47. And you can make M, this was M, 1.47M. That's a 3M minus 1, but that's 1.53M. This would be 124 times 1.47 minus 48, I think. And then divide the whole thing by 1.53. Okay, hopefully I've done the math correctly. Try and now tell me the value. What's the value that you're getting?
$87.76.
So you're getting 80. M comes out to be the M was the AR of the metal, the unknown metal. That's 87 point whatever, that's 7. TK 87.7. And that's probably, I don't know actually. I just have to strontium or barium. No, it's not barium, it's strontium.
Yes, sir, it's strontium.
So TK. Strontium is, so it's going to be D. Again, दूसरी approach, if you had used the other approach, it would have taken a very long time. Because the last one was the correct option. Yes.
Sir, if we go for the cross multiply method, like if 3 gram is producing 1.53 gram, and then we compare the MR, M plus 124 is equals to 108, and then we cross multiply, we will get the same answer.
Need 3 grams of?
3 grams equate 1.53 gram of the gases, and then we equate the
ratios,
MR and then cross multiply.
हाँ ठीक है, you could have gotten the answer that way as well. ठीक है, लेकिन उसके अंदर भी it would have been very time consuming because for every time you have to calculate the ratio again. क्योंकि MR calculate करो, first का करो, second का करो, third का करो, fourth का करो, ठीक है?
नहीं सर,
So every time you
one step, एक step में आंसर आ गया,
किससे?
तो डायरेक्ट m की वैल्यू आ गई है, जो मेटल की जो mr है उसकी वैल्यू आ गई एक ही बार।
अच्छा इसमें, हाँ ठीक है, this is exactly what we did cross multiply, ठीक है? मतलब वही करना है, ठीक है, तुम्हारी बात ठीक है। But you basically talking about the KMR का ratio लगाओ, it would have given you the same thing, ठीक है? As the next one is, but end में you would be solving the same thing, same exact thing, same expression. You would get the same expression. As the next is what happens when a piece of magnesium ribbon is placed in cold water. Remember, magnesium is not going to give a vigorous effervescence. It's going to, magnesium doesn't float. Group 1 metals are the ones that float. And it's not going to glow, it's going to be a very slow reaction. It's so B is the answer. Remember, in group 2, the reactivity increases down the group. Your first one, that's magnesium hardly reacts. It's a very slow reaction. Calcium kind of reacts, bubbles, and as you go down the group, strontium and barium, they react more vigorously. So the next one is compound X releases carbon dioxide gas and forms a white solid. Why? When it is heated. So it's decomposing. It's a carbonate, and so it's either MgCO3 or it's CaCO3. Let's read the first statement again. Compound X releases carbon dioxide gas. So it's A or B because B and D cannot release carbon dioxide. They don't have carbon in the first place. फिर उसके बाद what's happening कि, and after that what he's saying is कि neither X nor Y are soluble in water. So what's the white solid that's being produced? That's going to be MgO plus CO2, और यहाँ पे क्या होगा? That's going to be CaO plus CO2, right? So that's the white solid. And he's saying that neither X nor Y is soluble in water. MgO for sure is not soluble in water. Calcium oxide is partially soluble. Or remember, MgO is a ceramic material. Remember ceramics. Ceramics are substances that have very high melting points, and they are electrical insulators. They use in extreme conditions. So the three ceramic materials most commonly use aluminum oxide, MgO, and SiO2, which is sand. I mean, you make ovens out of clay. Why do you make ovens out of clay? Because it's very resistant to heat, and it has a very high melting point. Hence, the answer is C. Well, जहाँ पे उसने refractory kiln lining or furnace lining की बात की है ना, that just makes it C. ठीक है, that's it. Calcium oxide is a very it's not a very strong substance. And why is MgO so strong? Because Mg is a small atom. So इसके जो ionic bonds होते हैं ना, they're very very strong. Smaller ions, they always form very very strong bonds because they have high charge density. एक तो वो छोटे होते हैं, they're all close together, and they have very very high charge density. अच्छा, उसके बाद what's the, just one second. Achha, now what's the next one? The next one is this one. Which diagram shows the electronegativity of elements Na, Mg, Al, and Si plotted against their first ionization energies? So basically, there are two graphs now. One is the electronegativity graph, and the other one is the first ionization energy graph. What's the electronegativity graph? Na, when you move to the right, the electronegativity. So the electronegativity, or the tendency for the atom to attract a shared pair of electron, it increases when you move to the right of the periodic table because you have more protons. Na has 11 protons, Mg has 12 protons, Al has 13, silicon has 14 protons. So you have more and more protons in the nucleus, so there's more attraction. That's the first thing. So the electronegativity axis, just focus on the electronegativity axis. You can focus on the electronegativity axis, but upward direction. Ignore the horizontal direction for now. So just go upwards. This is the correct order. Ignore the horizontal direction. Na, Mg, Al, and Si. So that's correct. The electronegativity axis is plotted correctly. Na, Mg, Al, and Si. Again, that's correctly plotted. That is exactly correctly plotted. Na being the least electronegative, then Mg, then Al, and then Si. Remember, we're focusing on the vertical direction. These two are probably incorrect because electronegativity, they've given Na as vertically, they've given Na as the highest, the most electronegative. That's wrong. And this one is wrong as well. So we've just checked one of the axes at the moment, the electronegativity axis. A and B options are the ones that look correct. Now, what happens to ionization energies, the first ionization energies across the period? What happens to them is, okay, they increase across the period, but, so for example, you have Na, you have Mg, you have Al, and you have Si. So it increases, and there's a dip at Al, and then it starts to increase again at Si. So what's the order of the first ionization energy? And this is how across the period you have, if I can just Google one graph. Okay, this is how the first ionization energy graph looks like across the period. That it increases, keeps on increasing. As you move to the right, you have more and more protons, so there's more attraction. But there's a dip at Al and there's a dip at sulfur because of a few things. At Al, what happens is that the electron is removed from a higher energy p subshell, so it's further away, more shielded, so kind of decreases. It becomes easier to remove electrons. At sulfur, the p orbital is completely full and it's paired, and there's spin pair repulsion because the orbital now has 2 electrons. So the electrons are repelling each other, and because of the spin pair repulsion, it becomes easier to actually remove electrons. So coming back to the question now. So what's the order? Now focus on the order on the horizontal axis. The order is, the least would be Na. So this should be the order on the horizontal axis. On the second highest ionization energy would be Al, followed by Mg, and the last one would be silicon. So this is going to be the order on the horizontal side. Na would have the least, Si would have the highest. The second highest would be Mg, and the third highest would be Al. So Na, Al, Mg. So it's going to be, now focus on the horizontal side. So it's going to be Na, Al, Mg, and Si. So B is going to be the correct option, because if you just focus on the horizontal direction, then the 4 elements are plotted correctly. Na being the lowest ionization energy, Si being the highest ionization energy, and Al being lesser than Mg. So Al would have an ionization energy that would be lesser compared to Mg. Is this clear?
Yes, sir.
So let's move to Sarvo. Clear? Yes or no? Is this clear? So again, forget electrolysis again. 17. Which statement about the ammonium ion is correct? Now the ammonium ion is again an example of dative bonding in which you have NH3. Now remember, NH3 is originally pyramidal. It's trigonal pyramidal with an angle of 107 degrees. But what happens in NH3 is that it forms a fourth bond, a additive bond with H plus 1. So it's basically 4 bonds. And when you have 4 bonds, it's now 109.5 degrees, and the shape of the molecule is tetrahedral. So ammonium ions are formed when ammonia behaves as a base. Ammonia behaves as a base, not an acid. This statement, option B, is incorrect. Option A is also incorrect because the angles are 109.5. NH3 is behaving as a base. It's accepting an H plus 1 ion. That's when you get NH4 plus 1. Ammonium ions are unreactive when heated with NaOH. That's also incorrect because ammonium ions are acids. Ammonium salts, they always react with bases. What happens is that they lose H plus 1 ions, and the base OH minus 1, it gains or accepts H plus 1 ions. So you have an acid base reaction. Ammonium ion, they turn into NH3, and OH ions, they turn into H2O. Okay, this is what happens when you have an acid base reaction. Whenever an ammonium salt like NH4Cl, whenever it reacts with a base like NaOH, what do you get? You get a salt like NaCl, plus it's going to form an H2O molecule, plus NH3 gas is going to be given off. So this is what usually happens. And you have an acid base reaction. The ammonium ions are not unreactive, they actually react with bases. And that's a test for ammonium ions as well. Make sure you remember that that it's used as a test. One second. It's used as a test for ammonium ions. Ammonium ions का test यही है कि you add a base, warm it with a base, ammonia gas is produced which turns damp red litmus paper blue. The last one is the one that's correct. Okay, once a dative bond, all bonds are going to be exactly the same. I said remember, okay, once a dative bond is formed, the nitrogen would not know which one is the dative bond. मतलब nitrogen के point of view से आप देखो तो all of them would look exactly the same. I mean, there are 2 electrons, there are 2 electrons here, there are 2 electrons here, and there are 2 electrons over here as well. But although यहाँ पे over here the electrons are, one of them is coming from H and the other one is from nitrogen. Like the nitrogen doesn't know that. It just knows that there are 2 electrons here in this bond, there are 2 electrons in this bond, there are 2 electrons in this bond, and there are 2 electrons in this bond. वो तो हमें पता है ना कि one of them is a cross and the other one is a dot. और यहाँ पे it's a dative bond, so both of them are dots. Nitrogen doesn't know that. For nitrogen, all electrons are exactly the same. So this is basically all bonds are going to be the same length. And once a dative bond is formed, remember, the charge would not just be on H plus 1, it would be on the entire molecule. Okay, once a dative bond is formed, this plus 1 charge is going to vanish from that point. Why would it vanish? Because uska to charge khatam ho gaya because it got a lone pair from here. Now the charge would be on the entire thing because the entire molecule now is electron deficient. Okay, the positive charge is going to be spread out over the entire molecule because it's going to borrow electrons from here. So there would be some positive charge on this. It would eventually get spread out over the entire molecule. And always remember that the atom doesn't know which one is a dative bond and which one is a covalent bond. Okay, the atom is completely unaware. It just sees 2 electrons, it sees 2 electrons, 2 electrons, 2 electrons. It doesn't know कि वो electrons कहाँ से आए, who's providing those electrons. For the atom, all electrons are the same. अच्छा, इसके बाद next one is कि the carbon monoxide, NO2 and sulfur dioxide are all atmospheric pollutants. Which reaction concerning these compounds occurs in the atmosphere? So the first one, okay, NO2 is reduced to NO by carbon monoxide, which is probably not correct. Reduced by carbon monoxide in the atmosphere. Never heard of this reaction. What we have heard about is NO2 getting reduced by SO2. Okay, SO2 is a very strong reducing agent. So what it does is that in acid rain, the SO2, the two pollutants, they react together. SO2 is a good oxidizing, it's a good reducing agent. It turns into SO3. Remember about SO2. Okay, you have to remember that there are very few good reducing agents. SO2 is one of them. SO2 is a pretty powerful reducing agent. It's used in food preservation because of that. Uh, so what SO2 does is it takes away oxygen from NO2 and NO is formed. So I think C is correct. That NO2 is reduced to NO by SO2. During acid rain, this is the reaction that's taking place. Carbon dioxide and carbon monoxide are not the ones, you've never studied those reactions of carbon monoxide or carbon dioxide reacting with SO2 or NO2. And also remember that carbon monoxide doesn't really spontaneously always oxidize to CO2. Carbon monoxide is pretty reactive uh, and it usually doesn't oxidize to CO2. It reacts with other things. It reacts with the hemoglobin in your blood. I mean, if it spontaneously oxidizes to CO2, then it's a very safe gas. The thing is, it's not spontaneously oxidizing to CO2. It actually reacts with other substances. It reacts with your hemoglobin in your blood and causes choking. अच्छा ये बस कर लेते हैं last two questions. You have now this is a redox reaction. You have to balance this equation. Uh, find the oxidation states first. Cl is 0, doesn't have any charge, uh, and it's changing into Cl minus 1. So that means it gains 1 electron, right? And over here Cl is plus 5. Like if you can calculate the oxidation states, it's O3. That's minus 6, so Cl must be plus 5. So Cl is changing into or loses a total of 5 electrons. So this is what's going on. So the number of electrons gained and lost, they must be equal. So you're going to multiply the first one by 5. So x must be 5. You need 5 Cl minus 1s so that the number of electrons gained and lost, they become equal. And you just need one y. I mean, one ClO3. You need one Cl plus 5. You don't want to multiply it by any number because 5 electrons is enough. It loses 5 electrons. The other one gains 1 electron, so you multiply that by 5. So x is 5, y is 1, and that would give you C. Because if you start balancing the rest of the equation, there would be 6 Cls over here, so there should be 3 Cl2s over here. So the answer would come out to be C. ठीक है, ये भी clear है? Zaib, is this clear?
Yes, sir.
So this last one right now. Which alcohol will react with an acidified potassium dichromate 6 to produce a ketone that contains 6 carbon atoms? So oxidation, potassium dichromate 6. So we've got oxidation happening, and अब बैठ के figure out करो कि ये क्या है. What's butane 1 all? That's but 4 carbon atoms 1 all. That's OH 2 dimethyl. That means second pair there's methyl, on the second there's another methyl. Anyways, this is a primary alcohol. Primary alcohols don't form ketones. This one looks like a secondary alcohol, but we'll have a go. Pent, that means 5 carbon atoms. 3 all means the OH is on the third one, and 2 methyl, so that's 2 pair carbon. If you focus on the carbon atom that's on the OH, that's definitely a secondary alcohol. Because it's bonded to 2 carbon chains. So this is a secondary alcohol. So that's going to be the correct answer. It's going to turn into a ketone. Secondary alcohols, they turn into they turn into ketones. This one is, I said, there was another part that he was asking about 6 carbon atoms, right? So this is 1, 2, 3, 4, 5, 6. So that's also correct because we can have a go at C as well. So that's 3,3-dimethyl pentan 2-ol. So that's pent is 5. 2-ol means the OH is on the second one. That's a secondary alcohol, but it's 3,3-dimethyl. So that's a carbon, 2 carbons on the third one. Now this is a secondary alcohol, but the number of carbon atoms are, I think, there's 7 now. So which is why it would turn into a ketone, but not a 6 carbon atom ketone. And the last one is a tertiary alcohol. It's not going to get oxidized. Pent 3-ol, that's OH being on the middle one, and 3-methyl, that's carbon on the third one as well. Now this one is a tertiary alcohol, and they don't get oxidized at all. So hence no oxidation for this. So your answer was B from the start. चलिए ठीक है, let's continue next time, probably the same time, ठीक है?
Okay,
चलिए,
sir.
okay then, take care.
Allah Hafiz.